Welcome to solverfy.
All right, so problem number 24 wants us to calculate both the Q value and the kinetic energies of the reaction products of the decay of a lambda baryon. So we're given this decay path that a lambda baryon decays into a proton plus a pi meson. So for part A, it wants us to calculate the Q value, which is just the energy released, which is going to be equal to the difference in energy between the lambda baryon and its products. So let's write down the mass energies for each one of these first here. So the mass energy of the lambda baryon is equal to 1115.7 MeV. The mass energy of a proton is equal to 938.3 MeV, and the mass energy of the pion is equal to 139.6 MeV. All right, so we can just plug those in. So delta E is equal to the mass energy of the starting particle minus the total mass energy of the final particles. C squared plus m pi meson c squared. So if we plug in our numbers here, it's 11115.7 MeV minus 938.3 MeV minus 139.6 MeV. So this gives a total Q of 37.8 MeV. All right, so now for part B, it wants us to calculate the kinetic energy of the proton and the pi meson, assuming that the lambda baryon decays from rest. So to start this off, we need to understand a couple of things about the problem. Conservation of energy, first off. So the conservation of energy states that since the total energy of the two particles has to be equal to the rest mass energy of the starting particle. So m lambda, the lambda baryon, the rest mass energy of the lambda baryon, is going to be equal to the energy of the proton, the total energy of the proton, plus the total energy of the pi meson. Now we can rearrange this a bit to state that the total energy of the pi meson is then going to be equal to the rest mass energy of the lambda baryon minus the total energy of the proton. Now next, if we look at this problem, we have this lambda baryon at rest, and then it decays into a proton and a pi meson. So now conservation of momentum states that since the momentum of the starting particle was 0, the total momentum of its decay products must also be 0. So since the momentum of the lambda baryon is equal to 0, then the momentum, I'm going to put vectors here because that's important, the sum of the momentums of the proton plus the momentum of the pi meson must also equal to 0. So that means that the magnitudes of the momentum of the proton must equal to the magnitude of the momentum of the pi meson. So they're going to be equal in magnitude but opposite in direction, so that way their vectors add up to 0. Now, if we look at the relativistic equation for energy, the total energy, E squared is equal to P C squared plus M0 C squared. So the kinetic energy of the particle plus its rest mass, which is given by its potential energy. Now if we look at our momentums here, since our momentum of our two particles are equal, and that means that our kinetic energies of the two particles are equal. So if we multiply both sides by C and square it, if we multiply both sides by C, which gives the kinetic energy term, it's the same. It's going to be the same. So we can state that P, the momentum of the proton times C squared is going to be equal to the momentum of the pi meson times C squared. And that we can plug into here. So from conservation of, I'm going to create a new page here. So from conservation of energy and from momentum and energy, we can write the kinetic energy, EP squared, from what we just wrote. So from what we just wrote here, the kinetic energies are equal. So that means that the kinetic energy can also be given by the total energy minus the rest mass energy squared. This is for a proton. It's going to be equal to the kinetic energy of the pi meson, or the total energy of the pi meson squared, minus the rest mass of the pi meson squared. Now we've already solved for this term here, the energy of the pi meson, which is given by right here. The energy of the pi meson is equal to the rest mass of the lambda baryon minus the energy of the total energy of the proton. So we can plug that in here, and we get total energy of the proton squared minus the rest mass of the proton squared is equal to the rest mass energy of the lambda baryon minus the total energy of the proton squared minus the rest mass energy of the pion squared. So clear. All right, so now we can expand this out and get the total energy of the proton squared minus, I'm just going to go ahead and expand this out, the rest mass of the proton squared is equal to the rest mass of the lambda baryon squared minus 2 times the rest mass of the lambda baryon times the total energy of the proton minus, so that's, plus the total energy of the proton squared. So all I've done is just expanded this squared out minus the rest mass energy of the pi meson squared. All right, so now we can simplify things. These cancel. Then we can move the mass energy of the proton over. So so let's do that. So let's do this one step at a time. M squared, m0, c to the fourth, minus 2 m0, c squared, ep, the energy of the proton, minus the energy of the pi meson, squared, so rest mass energy of the pi meson squared, plus the rest mass energy of the proton squared. Now we want to solve for the energy of the proton. So we move this over here. We add this to both sides. We get 2 times the rest mass of the lambda baryon times the total energy of the proton is equal to the rest mass of the lambda baryon squared minus the rest mass of the pi meson squared c to the 4th plus the rest mass of the proton squared. Now we can solve for the total energy of the proton by dividing both sides by 2 times the rest mass of the lambda baryon. So we get the total energy of the proton is equal to m squared c to the 4th minus m pi squared c to the 4th plus p squared c to the 4th divided by rest mass of the lambda baryon, c squared times 2. All right, I'm going to create a new page here because now we have to plug in all these numbers since we have all of those. So I'm going to rewrite that. The total energy of the proton is equal to the mass, the rest mass of the lambda baryon squared minus the rest mass of the pi meson squared plus the rest mass of the proton squared divided by 2 times the rest mass of the lambda baryon. Now we can plug all these values in since we have them. This is going to be equal to 115.7 MeV plus that's squared plus 938.3 MeV squared minus 139.6 MeV squared divided by 2 times 1115.7 MeV. Gives a value for the total energy of the proton of 943.7 943.7 MeV. So that's the total energy of the proton. So now we want to work out the kinetic energy of each particle. So we've already worked out that, so this is the total energy of the proton. Now we need to work out the total energy of the pi meson. So the total energy of the pi meson is going to be equal to, which we solved for back here. So that's going to be equal to the rest mass energy of the lambda baryon minus the total energy of the proton, which is going to be equal to 1115.7 MeV minus 943.7 MeV, which is going to be equal to 172.0 MeV. Finally, the kinetic energy of each particle is given by its total energy minus its rest mass energy. So that's given by 9. So its total energy of the proton, 943.7 MeV minus 938.3 MeV, so its rest mass, is equal to 5.4 MeV. And the kinetic energy of the pi meson is equal to total energy, minus its rest mass energy, which is equal to 172.0 MeV minus its rest mass energy, which is equal to 139.6 MeV, which gives a total kinetic energy of the pi meson of 32.4 MeV. All right, so that gives you the total kinetic energy of each particle using conservation of momentum.